Hello viewers, I am Osiaje Harvest, a physics teacher, and today we'll be looking at something very interesting titled vectors. Now, what is a vector quantity? A vector quantity is simply a physical quantity that has both magnitude and direction. Now, when we talk about magnitude, we're talking about the size. You cannot talk about a vector quantity without showing its direction. And there are ways by which we can represent vectors. But before talking about how we can represent a vector, there is need for us to talk about examples of vector quantities. Some of the examples include displacement, acceleration, velocity, and the rest of them. There are very many, just to mention a few. But what we'll be dwelling on mostly today is how we can represent vector and how we can get some vectors added up. Now, to represent a vector, we use a straight line that has an arrowhead. Now, this straight line represents the magnitude, that's the size, while the arrowhead talks about the direction. So what we are having here now, we are having a vector quantity that has the size pointing to the direction of the east. Now, for us to get the size here, you can get a ruler, measure the length, and also the length. So let's assume this one is 3 centimeters long to give us a vector of 3 centimeters in the eastern direction. So that's how we represent a vector. Now, for us to add vectors up, there is a simple rule we follow. For example, now, if you have two vectors acting in the same direction, let's say this is vector A and this is vector B. Now, if you have two vectors in this manner, I want to get them added up. What you do is just for you to get the sum of A and B. And that value we get now, we call it the resultant. So we can say A plus B is equal to what? The resultant vector. Now, lest I forget, what is a resultant vector? A resultant vector is that single vector that will have the same effect in magnitude and direction as the original vectors acting together. I repeat, a resultant vector is that single vector that will have the same effect in magnitude and direction as the original vectors acting together. Meaning, when you bring the original vectors together and you sum them up, the effect you'll be having will be what we call the resultant vector. This first case now is for two vectors acting on the body in same direction. Now, if you have a body placed this way and you have two vectors acting on it in the opposite direction, let's say this is vector A and this is vector B. Now, to get the resultant in this case now, there's a rule we have to follow. The rule we follow here now is that we get the difference in the two vectors. You are going to get the difference, removing the small one from the bigger one. Then the resultant will be in the direction of the bigger vector. Now, we check line A and line B now. We're going to find out that line A is shorter than line B. So in this case now, our resultant is going to be pointing in this direction. This will be the direction of your resultant vector. So you can say for this now, resultant arrow will equals B minus A, the larger vector minus the smaller vector. So for vectors acting on a body, if you want to get the resultant, these are the simple rules we use to go about getting them. But there's another case again, which we can talk about. This first case, this second case, on simple vector addition. Then, if two vectors are acting on a body at right angles to each other, to get it is very simple. Let's say, for example, two vectors. Two vectors of 3 meters per second and 4 meters per second, so now are representing velocities, act on a body in the eastern and northern direction, respectively. Determine their resultants. Okay, if you have a case like this, it's quite different from what we have here. These ones are just vectors acting on a straight line on the body. In this case now, we have them acting at an angle, that is at a right angle to each other. So what you do in this case, you get the starting point. Let's say this is the point O. So you take, you get a ruler, measure 3 centimeters. You measure 3 centimeters. But in this case now, since you have it in meters per second here, you write 3 meters per second. Then at the end point of your 3 meters per second, you get your ruler again, measure 4 centimeters. And you must put the direction. Remember, I was talking about eastern and northern. So the first one is, the other one north. You put the arrow direction showing it's pointing towards the north. Then you put the value there, 4 meters per second. So what you do finally, you join the ending to the starting point. So when you join the ending to the starting point, the line here now will give you your resultant. Remember, this is at right angles to each other, then this is your angle of inclination to the horizontal. Then finally get your ruler, measure this line. The value you get on this line will give you the resultant. And take note of the direction which the resultant will be pointing to. If this is east, if this is east and this is north, and the end will be pointing towards, it will be pointing towards northeast. So the value you have will be in the northeastern direction. Now your measurement is very accurate, and you have this done already. Your answer will be about 5 meters per second, and the direction will be what? Northeast. So that's all. Using the scale drawing method. This scale drawing method. Scale drawing method. That's for this one. And using this, you must set your scale at the bottom of the diagram. Now the scale we use here is 1 centimeter representing 1 meter per second. So that's for the scale drawing method. Also, we can use a different method, and let's see if we will see arrive at what we are having here. Okay, now let's try using Pythagoras theorem. Using Pythagoras theorem. Now for Pythagoras theorem, we say I squared equal to P squared plus Q squared. Now we take the first vector as our P. I'll take the second vector as our Q. Okay, now let's go there. You say that I squared now is equals 3 squared plus 4 squared. Take note, the first one is the P, second one is the Q. Okay, now when you square 3, what are you going to have? The square of 3. So you say I squared. 3 squared is 9. Then 4 squared is 16. Okay, what to do next? You add up 9 plus 16 is going to give you 25. Now, since you have square, you are not looking for the square of the resultant, you are looking for the resultant. So what you do next in this case now, take the square root of both sides. Square root of this and square root of this. So your area now becomes 5 meters per second. And remember, you must take the direction of east or north, or you call it northeastern direction. So that's another way of adding up vectors acting at right angles to each other. It's either use the scale drawing method or you use the Pythagoras theorem method. Then another method again of adding vectors is the parallelogram law of vector addition. Now, take a parallelogram. These are parallelogram at first. Remember we said this side and this side, they are equal. This side and this side, they are opposite and also they are equal. Then this angle and this angle, they are equal. This angle also is equal to this angle. That's for a parallelogram. Now the diagonal will be drawn from this point to reach this other point. That's for a parallelogram. Now the final law of vectors, it states that if two vectors are represented in magnitude and direction by the adjacent sides, now bringing this side and this side of the parallelogram together, it states that if the diagonal drawn from the point of intersection represents the resultant vector in magnitude and direction. I take that again. If two vectors are represented in magnitude and direction by the adjacent sides of the parallelogram, the diagonal or the parallelogram drawn from the point of intersection of the vectors will represent the resultant vector in magnitude and direction. So now you get these adjacent sides together, get their value, that's the magnitude of them and the direction. Then what to do next now? The diagonal that you get to the last point of the parallelogram, that is going to give you the perfect value of the resultant. Let's get an example on this first. Example on parallelogram method of vector addition. Okay. Now let's have it that if two vectors are acting at a point, if two vectors of 3 newtons and 4 newtons are acting at a point O, are acting at a point O at an angle of 45 degrees with each other, determine their resultants. Okay, two vectors acting at a point O, and now we have been given the angles, the angle between the two of them, and the angle is just 45 degrees. Now we want to use a parallelogram to see how we can add this up. So what do we need to do at first? We need to get the starting point. We need to get the starting point of the two vectors. Get the starting point of the vectors. Okay, let's say this is starting point. Remember talking about the parallelogram, and it's very wise for us if the horizontal line is the longer part. Then we have 3 newtons and 4 newtons. But if we make 3 newtons to be the horizontal line, it's going to look somehow upward. So just try as much to make the 4 newton to be the horizontal line. So the first method by using it is scale drawing. Using scale drawing. That's the first one we use before we try the other method. Scale drawing method. Okay, now you get the point O. Measure your line of about 4 centimeters from the starting point. Since your notebook can accommodate 4, you measure that 4 centimeters from the starting point. Okay, I will do mine here. 1, 2, 3, and 4. Okay, and I'll put the arrow direction showing this because a vector quantity is not complete unless you indicate the direction. So I'll put 4 Newton here. Then I'll get my protractor and measure angle of 45 degrees from this point. So you place a protractor here and measure 45 degrees outwards. Please, you can do that at home. Get your protractor, make sure you're not drawing it with free hands. Get your protractor, measure 45 degrees outward. Then, after you got it to 45 degrees, get your ruler and measure 3 centimeters. 3 centimeters. I'm just assuming this is my 45 degrees. So take 3 cm this way. Okay, now you've gotten these two known parts first. Now to get this upper part, remember the parallelogram, the opposite sides, they are equal. So you draw 4 cm here as well. 4 cm as well. Okay, then you have to join the ending to the starting point. And when you measure this, it's going to give you the 3 cm of this other side. Remember, here is 3 Newton. Then finally, you draw the diagonal of the parallelogram. You draw the diagonal outwards. And this diagonal now is going to give you the resultant vector. Remember, the angle here is 45 degrees. So in this case now, you must take the scale used here. The scale used here is 1 centimeter representing 1 Newton. Now to get the resultant, you just measure this line. Measure this line, and this line will give you the value of your resultant. Make sure you measure it, and if you measure it, you must get the accurate value of the resultant if everything is properly done. Now, if you have to try using the cosine rule, you must get the value of this angle. Because we check that it's just like a triangle. So we must get the value of this angle. Now, how do we get the value of this angle here? Remember, for a parallelogram, the sum of the angles in a parallelogram add up to 360. Okay, outside the opposite angles, they are equal. If here is 45, here is also 45. So you have 45 plus 45. That has already given you what? 90. Now, how do you get the value of this angle and this angle? Just remove 90 from 360. When you remove 90 from 360, you are going to have, here is 0, over 1 here, here are there, 7, and these are 270. Now, this 270 now is the value of this angle and this angle put together. So divide 270 by 2. That will give you 135 degrees. So here's 135. It will also be 135. But we want to dwell more on this triangle. So now let's try to see what we get using the cosine rule. Using the cosine rule. Okay, now for the cosine rule, we have that I squared is equal to p squared plus q squared minus 2pq cos theta. So that's for the cosine rule. I squared plus p squared plus q squared minus 2pq cos theta. Okay, now fix in the values of our p and our q. Let's see what we are going to have from there. Okay, now you say r squared equals, now let's say our p now is 3 squared plus our q is 4 squared minus 2 into 3 times 4. Then cos, now you tell the time it might have to be 135. If you have to use your Pythagoras table, you're not going to get 135 inside of it. So in the absence of calculators that may be, you want to use your Pythagoras table, what you need to do in this case now, you have to pay 180 minus 135. That will be the value of your theta. Remember, this part is different, all the other parts they are together. Okay, now our I square now will be equals 3 squared is 9, First one is 16. Okay. Minus 3 times 4 is 12 times 2. That to be 24. Minus cos. Okay, multiply by cos 45. 180 minus 135 is 45. But in this case now, if you check what we have here, we have 135, which is greater than 90. So in this case, if we remove 135 and 180, we are going to have minus cos 45. Now, how does this happen? That will take us to our 4 cardinal points, or the 4 quadrants. Now, for the 4 quadrants, there is a simple way we go about things. We have this for all the values. This one is for sine, this one is for tangent, and this one is for cosine. We can simply say add sugar to coffee. Okay, now this quadrant is positive for all values from 0 to 90. Then this one, we have values of 90 to 180. Then the values here is 180 to 270, and the values here will be 270 to 360. Okay, now you have 0 to 90, you have 90 to 180, you have 180 to 270, you have 270 to 360, all in degrees. Now, for all values in this quadrant, everything you have here is positive. Now, when you go to the second quadrant, from 90 to 180, it's only values of sine that will be positive here. If you bring tangent in here, it's going to be negative. If you bring cosine in here, it's going to be negative. Then, this is our top quadrant now, from 180 to 270, is only positive for the values of tangent. If you bring cosine here, cosine will be negative. If you bring sine here, sine will also be negative. Then the last quadrant is from 7 to 360, stands for, is positive for all cosine values. If you bring sine here, sine will be negative. If you bring tangent here, tangent will also be negative. Now, going back to what we have here, our question, you have the value here to be 135, which is falling into this quadrant where you have for sine. Now, since the value is for sine, that's why our cosine value I'm getting here will be negative. So that is where the negative sign is coming in our calculation now. Okay, so now we can move further. So we can say our R square now. R square now equals, if you add 9 plus 16, we're going to have 25. 9 plus 16 is 25. Then minus 24 multiplied by, if we check for cos 45, we're going to have 0.7071. Then bring minus sign down, minus 0.7071. Then from here, you can just simply do the normal arithmetic here. I squared equals 25. Now, you have 24 here, you have minus here. So multiply the minus by the minus you have here, it's going to end up becoming plus. Okay, now if you multiply 24 by 0.7071, multiply 24 by 0.7071, they are going to have a 41.970. Okay, 24 multiplied by that by 0.701, 16.9704. 16.9704. Okay, now let's try to add this up. R square now becomes, add this up, I'm going to have a 41.9704. Okay, now you still have square on the resultant. So now to remove the square, you take the square root of both sides. So you take the square root of this, take the square root of this. So this and this will go away. So now our R now, let's see what we have for it now. We're going to get the square root of 41.9704. Square root of 41.9704 9704, and that will give us 6.48. 6.48 Newton. Now we check the direction of our resultant. It's pointing in the northeast direction as well. So we say 6.48 in the northeast direction. That's east of north. So falling back here now, if you did this, I have something around 6.4, you are correct. That's something around 6.5. You are also correct, because in every measurement there might be one or two little mistakes. So if you have anything close to this range, it means you are still close to our final value. So that's for how to get our resultant. We've talked about how to get there when they're acting on a straight line. We've talked about how to get resultants when they're acting or at right angles to each other. Then we also talked about how to get resultants using the parallelogram method of calculation. Now, let's assume this angle now, there's a value here, theta, and we don't know what is here. There is another simple way we can get the value of the angle theta, and with that, we can use the sine rule. We can use the sine rule to get the value of the angle theta. Now, in this case now, let's say the value of the angle theta can be obtained using the sine rule. Now, this sine rule was gotten from Lami's theorem. Lami's theorem. And Lami's theorem states that if three forces acting on a body keeps it in equilibrium, then each is proportional to the sine of the angle joining the other two. Let's assume we have these three from a body of equilibrium. Then each of them now has each of the forces of the angle joining the other two. Okay, now it means this will proportional to the angle joining these two. Then this one now, this angle here. Okay, now let's try to see what we get using the sine rule now. Now it means that this angle joining these two will proportional to this side. The angle joining these two will proportional to this side. Then the angle joining these two will also proportional to this other side. Okay, now let's try to go there. Let's say sine theta over, now this sine theta now, the angle joining these two proportional to this other side. If there is 3, there will also be 3. So sine theta over 3 will now be equals, these are sine 135, and we have our arrow ready to be 6.48. So we can say that is a sine 135 over 6.48. So now, how do you get the theta then? We just try to make theta the subject of the formula by trying to cross multiply. So we can cross multiply, then we can say sine theta now cross multiplying sine theta now equals 3 sine 135 divided by 6.48. Let's try to see what we have there. 3 sine 135 divided by 6.48. 3 divided by 135, then let's divide by 6.48. Okay, I think multiplying and dividing, we have 0.3274. 0.3274. Okay, now to get just theta instead of sine theta, you move the sine to the other side, and what is called this over will become the arc sine of the value you have there, or the sine inverse of the value you have on the other side. So your theta now becomes sine inverse of 0.3274. Arc sine of 0.3274, and that will give us 19.1 degrees. So the angle that is between our resultant and the resultant now is 19.1. It will be very careless of you if you just say this is 45 and divided into 2 and then just get the value to 55. No. you are divided, maybe divide that into 2.5. That's not correct. You can see from here that as well something very different from that, because this angle was not actually a right angle. So that's why you have a different value there. So it's very wise for you to calculate to get the value of your theta. Then also, if your measurement was very accurate, if you get a protractor and place it here, you will also get something close to either 19, 20, or even 18. If you have any value in that range, 18, 19, or 20, you know you are very, very accurate too. So I think with this, we have come to the end of vector addition. In case you have any question or maybe any contribution, you can reach me on my WhatsApp via +23480 387 99304. The number again, +23480 387 99304. Thank you for watching. Have a great day. Thank you for watching.